Hello dear students, in the previous lecture I have discussed about the path of a projectile. What was it? Yes, you are right, parabola. Path of a projectile is parabola. Today I am going to discuss about the time of ascent, maximum height, horizontal range, time of flight and velocity at an instant of time. Very interesting. Remember these steps in how I am going to derive the formula. If you can remember the steps how I am going to derive the formula, you can solve the problems easily. I never ask my students to mug up the formula. I ask them to remember the method in which we are deriving the formula. That helps you to solve many problems. See, many students mug up the formula and they follow the problem solving techniques or the solutions of the problems taught by the teacher, or they see some books and they try to find the solutions. Even in internet also students are trying for solutions. I don't actually encourage this, because once you are habituated to check for the solutions, your mind automatically try to find the solution from some different source, not from here. I encourage you to find the solution of any problem from this source, not from any external source. Here I am giving you solutions for some problems. It is just one path. It is giving you one direction. How to solve some problems. I am giving you some techniques. That's it. It doesn't mean that I am going to explain all the problems available in the universe. It is never possible, and even I will never do it. I will discuss very few problems. I will give you the full length concept. By using this full length concept and by solving few problems from my side, you have to apply the concepts and you have to solve the problems by yourself. Daily try at least 20 problems or minimum 10 problems also. A good habit. Make a habit of solving 10 problems from any reference book. I don't mention any name. It could be any reference book available in the market or which is in our ebooks button, ebooks link, or in your hands. Okay, so try as many problems as you can. Never search for the solutions in the internet or somewhere. Even if you can't solve 10 problems per day, I know in the beginning it's not possible to get solutions for 10 problems in the single day. Maybe in the beginning you may get solution for 10 problems. Don't worry. My God, today I have tried a whole the day, I got only one solution. I have wasted my time. No, it's not wasting your time. You are digging your mind. You are thinking, you are trying. So it helps you a lot. In 2-3 days, your graph increases. In the next day, by next day, you can solve 2 problems at least out of 10. Within 3-4 days, your graph reaches to 4, 5, 6, 7, 8. From then, it becomes slow. So there is a very near future in which you can solve at least 8 problems out of 10. So don't search for solutions. Think. Okay? Follow my concepts, listen my concepts. I will give you some techniques. Follow these techniques, apply these techniques. You can solve the problems. See, learning is different, marks are different. The question which you have studied, the same question came in exam hall, you wrote that and you will get the answers and you will get the marks. That is a different issue. But in competitive exams, we get new questions, always new questions. We have to face new questions. For that, we need to prepare ourselves to face new problems. For that, we have to try new problems every day. Okay? Well, come here. My first topic is the time of ascent in case of a projectile. See, as we discussed previous, this is a parabola which is moving like this. Which is moving like this. say this is the highest point. After that it comes like this. What is the velocity at the highest point? It has two components of velocity as we have discussed. Along x-axis ux is equal to u cos theta and uy is equal to how much? 0 here. We say that the body is at the maximum height when its vertical component of velocity becomes 0. As the vertical component of velocity becomes 0, it can't go beyond. That's why the moment when it is at the highest point, its vertical component of velocity becomes 0. Now I am discussing about time of ascent. So as in the previous case we have discussed about time of ascent. The same definition here also. The time taken by a body to reach maximum height is called as time of ascent. So now when the body reaches to maximum height, what is its vertical component of velocity? Uy, u sin theta. Don't say this. We are discussing about vertical component. The moment when it reaches to maximum height means we are discussing about vertical component, not along x-axis. So when we are discussing about time of ascent, we need to discuss about vertical component only. That's why in this case the final velocity Vy becomes 0. Uy, where initial velocity is equal to u sin theta. So I am going to apply our formula. V is equal to u plus at here. What is that? V equal to u plus at. I am discussing along a y-axis. That's why it is y. So what is our Vy? 0 is equal to uy means how much? U sin theta. U sin theta plus ay means what? G, acceleration along y-axis. Anywhere, here, anywhere it is g only. G only. So g into t means I am going to write time of ascent Ta. Now what about the sign convention? Initial velocity in the upward direction, g in the downward direction. If I take this as plus, this is negative. If I take this is minus, this is positive. So I am going to take this as plus, this should be minus. So this is plus, this is minus. So if I send this into this direction, gta is equal to u sin theta. Now from this, what is our Ta? Ta is equal to u sin theta by g. So the time of ascent depends upon initial velocity, means velocity of projection, and also angle of projection, with which g, however, at a place remains constant. So when you can achieve when do you think the time of ascent is maximum for a particular velocity? Depends upon this. So its maximum value is 1, that is when theta is equal to 90. Means a body is projected vertically like this, vertically upwards, then the time of ascent is maximum. This time of ascent, does it depend upon mass or any other factors? No. Here it purely depends upon initial velocity and angle of projection and gravity only. It is independent of the mass of the body. Even if you throw this or a big stone, if the velocities are same, the time of ascent will be same for both. Now let us discuss about time of flight. Time of flight. See, from the definition of time of flight, we can derive the formula for time of flight. What is the definition? Earlier we have discussed many definitions for time of flight. The same here also. The time of ascent plus time of descent is called as time of flight. At the time in which the body remains in air is called as time of flight. Or the time in which the vertical displacement becomes 0 is called as time of flight. Because this is our horizontal displacement, this is our vertical displacement. Initially, what is its coordinate? 0, 0. After some time, if this is something x, so this is x, 0. So what is the vertical displacement? Initially it is a 0 component, finally it is at 0. So the vertical displacement is 0. So the time in which the body reaches the ground, or the time in which the body remains in air, the time in which the vertical displacement becomes 0 is called as our time of flight. So here also I am discussing about vertical displacement. So what is our formula for displacement? S is equal to ut plus half at square. So S means vertical displacement 0. Everything is y. Uy means what? U sin theta. Into t means what? Capital T. plus half. Ay means what? G into t square. Now let us check the sign convention. U is upwards, G is downwards. So if it is plus, this is minus. So this plus, this is minus. So half G into t square is equal to how much? U sine theta into t. This t gets cancelled and t equal to how much? 2u sine theta by G. This is our formula for time of flight. See, it is exactly double. U sine theta means time of flight is equal to 2 times of time of ascent. Is it clear? Now, on what factors this time of flight depend? Same as time of ascent. It depends only upon the initial velocity with which it is thrown and the angle of projection. It doesn't depend upon mass or any other factors. So, when do you think the time of flight is maximum? When theta is maximum. What is the max value of theta? Sin theta. Sin theta 1. The max value of sin theta is 1. So, it is possible only when theta equal to 90 degrees means when it is thrown like this. So when an object is projected vertical upwards, the time of flight is said to be maximum. Is it clear? Now let us discuss about maximum height. From our definition of maximum height, we can tell the formula. You can derive the formula. Now let us see what is the maximum height. Definition. The position at which vertical component of velocity becomes 0 is our maximum height. So the moment when it reaches here, the velocity component becomes 0. So the moment when its velocity component becomes 0, we can say that the body is at maximum height. So ux is equal to, now we have to discuss along y-axis only. Max height means it is related to y-axis. Uy equal to how much? U sine theta. Ay is equal to how much? G. And Vy equal to how much? 0. S is equal to H. This is our formula. Yeah. Uy, velocity along y-axis is equal to U sine theta. Ay equal to minus G. Vy equal to 0. Sy equal to H. I am going to apply my third equation. V square minus U square equal to 2as V square means the final velocity becomes 0. 0 square minus U square. U sine theta. U sine theta whole square equal to 2 into A means G because it's Y. ds means H max. But what about this G? Minus. If this is Uy is in the upward direction, this G is in the downward direction, it's minus. So minus. Now this minus gets cancelled and is left with U square sine square theta equal to 2G H max. H max equal to how much? U square sine square theta by 2G. So these are max height. So now on what factors does the max height depend upon? It also depends upon initial velocity and angle of projection. When do you think that the body can reach maximum height? If the initial velocity is increased, the body can reach maximum height. Or even if the angle is changed at theta equal to 90, it is maximum. So if it is thrown vertically like this, it reaches maximum height. Then this. In all the cases, the initial velocity is same, but the angle of projections are different. That's why it reaches to different maximum heights. But in this case, it reaches the maximum height. So U square sine square theta by 2G. However, at a particular place G remains constant. You can say that H max is directly proportional to U square, as well as H max is directly proportional to sine square theta. Is it clear? These are maximum height. Now let us discuss about horizontal range. Horizontal range is discussion about x-axis. So now whenever we discuss, we need to discuss along x-axis. I am going to use this formula. S is equal to ut plus half at square. So what is our definition of horizontal range actually? The displacement along x-axis during the journey, or the displacement of the object along x-axis during the time which is equal to time of flight. So during the time, after this time the journey has been completed. That's why the displacement of this object during the time which is equal to time of flight. That's all. So S is equal to U into, U means here I have tried Ux, half into X, Ux into T, capital T, plus half X. What is the acceleration along x-axis? You are right, 0. So acceleration along x-axis throughout the journey is 0 for projectiles, whereas acceleration along y-axis is z always, wherever. So it is 0. So this is equal to how much? Sx means our range is equal to ux means u cos theta into time of flight. We have discussed it already. 2u sin theta by g. Now this u into u square into what is this? 2 sin theta into cos theta. 2 sin theta into cos theta by g is our range. What is this 2 sin theta cos theta? This is nothing but sin 2 theta. So r is equal to u square sin 2 theta by g is our horizontal range. Is it clear? Say with me. Horizontal range equal to how much? U square sin 2 theta by z. What is the technique I have used here? I used the technique that the displacement of this body during the time is equal to time of flight. In this time duration, what is the displacement? Is nothing but time of horizontal range. U square sin 2 theta by g. Now on what factors does this range depend upon? This range depends upon at a particular place u square. If the velocity is more, range will be more. See, for example, if I throw this object like this with certain velocity, maybe the angle is same. If I throw the object with certain velocity, it moves here only. If I throw the object with some increasing velocity, it reaches some more distant apart. If I throw the object with some more velocity, it moves some more distant apart. So it depends upon the initial velocity. Also r is proportional to sin 2 theta. If this is maximum, this is also maximum. So when do you think this is maximum? Then sin 2 theta equal to 1 is this range is maximum. When do you think sin 2 theta is maximum? When sin 2 theta is equal to 1, that is our maximum value. When it is possible? When this angle is equal to 90 degrees, means 2 theta is equal to 90 degrees, the range will be maximum. Means theta equal to how much? 45 degrees. If you can throw an object with an angle 45 degrees, it reaches maximum range. If the angle of projection is 45 degrees, the range will be maximum. Try to throw some stones with different angles with same velocities and see in which case it reaches maximum range.